Assalamualaikum warahmatullahi wabarakatuh. I would like to talk about the continuation of the completion fluid. So let us doing this exercise, how to calculate the average density. The first is we calculate average temperature, and then average temperature increase ATI, and then density loss due to temperature, and then average hydrostatic pressure to calculate the density gain due to pressure, and then finally the average vapor density that we expected to have in the gun. So this is the example. We have 12 ppg natrium bromide brine with 70 degree Fahrenheit in the surface and 230 degree Fahrenheit in the bottom, with perforation is 9,902 and 10,008 feet. So the average, the middle perforation is 10,000. And then what is the average of the density? That's the question. And this is the step by step how to calculate this one. And in order to do this, I have something like this. So from these equations, I put 1 by 1. Surface density is 12 ppg. Surface temperature 70, bottom temperature 230. This is perforation. So the average of the temperature is between surface and the bottom. So 70 plus 230 divided by 2 is around 150 degree Fahrenheit. And then we measure the API, standard measured temperature ATI, which is AT minus ST. AT is 150, ST is 80. Surface temperature, so it's become 80. And then we calculate density loss. Density loss to the temperature, we have a factor here. The table of factor depends on the brine type. So the bottom is higher on ppg, smaller density. So the density loss due to temperature is this factor multiplied by this 80. So in this case we have a natrium bromide, we use 0.0033, and then if you multiply it, become 0.264 ppg. Then the fourth one, we calculate the average hydrostatic pressure, H. Surface density minus density difference density loss due to temperature, which is 2.6, and multiply by 0.052. We'll explain why this 0.052, and then multiply by TVD. And then surface density minus density loss multiplied by TVD, and then the mid perforation TVD. It should be in the mid perforation with top perforation plus bottom perforation by 2. So this is around 10,000. So this is 10,000. So the EH from this calculation have a 6,103 psi. And number 3, from this average hydrostatic pressure, we have a gain in this one is dg. It should be dg is 0.128 ppg is coming from this one multiplied by this AH. So this factor is another 0.000021 multiplied by 5103. So we have this number. And finally, this is what is this should be dg. Okay. So the average vapor density is SD minus DL plus DG. This is DG. So this is the final number. And would like to mention a little bit about this derivation of 0.02 is actually coming from engineering unit. The engineering unit for F m equal to G, basically what we have is actually this 1 over GC. GC is gravitational constant, it's a constant. Everywhere you go is constant. G is different. If it's in the subsurface become 32.2. If in the mountain area, in the very high mountain, it become around 31, 30 or something like that. It's different number for different height. But for GC it's a constant. And then if we put the number in here, 1 equal to point force. Okay, 1 point force F. GC actually is 32.2 pound mass feet divided by 0.4 second square. This is called GC. M is pound mass and G is 32.2 feet per second square. Okay, so if we divided everything with this with the feet cube, so I have this number here. Okay, and this number, let's see the pound force per feet cube. We can rearrange everything to become something like this. So the in square, we put in square to get the PSI, multiply by 144, and then we have a PSI per feet, so we have multiplying of 144. And then to the right, we have this pound mass per foot cube to get the this is the density. Okay, and then the density is divided multiplied by 7.8 to get the feet cube per gallon. So we have a feet per gallon. So we end up with having something like this. Okay, PSI per feet, PSI per feet with in square per feet square, and then the whole number is still here, and 7.8. And then so we talk about 1 PSI per feet equal to this one ppg, and the whole thing is coming up here. And this is what I want to talk about here. So basically we eliminate everything, and then this is what we have. 1 psi per feet is equal to 0.02 ppg. So basically this one is a force, this one is a mass. Okay, pound force, pound mass. So let's go back to this equation again. If we want to say, in this case, 1 pound force is caused by 1 pound mass of a mass. So it is different with the SI. This and SI 1.4 1 Newton equal to 1 kilogram meter per second square. But in this case, 1 Newton. But in this case, that if you have 1 pound force, it is caused by 1 pound mass. Okay, so because 1 pound mass have an acceleration, so it end up being the same as 1 pound force. But it's different with the international standard. 1 Newton, 1 Newton equal Fmg. So if it's 1 kilogram and G is 9.8, so 1 kilogram causing 9.8 Newton. So it's different. Okay, so this is why we end up with having 0.052 So that's why we have a from pound force become a ppg. We go back to here. Okay, this is the pressure. So this one is from ppg. Okay, this is a mass, this is pound force, this is pound mass, this is pound force. Why we end up with 0.052 due to the explanation that I give it to you in the part. So I will give you this one part as a homework. Please do it. Okay, thank you.